Hello everybody, I'm Marco Dambos, and today we are going to see how to build a spline Bezier in Maya with Bifrost, and just to be specific, a cubic spline. I already made a video how to build a curve Bezier based on the Castillo algorithm, and that was to show how to use the do while and how to combine the LARP together. In this particular video, we are going to focus on how to compute the polynomial, then describe a cubic Bezier, and how to use the matrix to do so. Spline is actually, in this case, a combination of multiple curves. So we are going to focus on one curve with 4 points because it's a cubic, so you need to have at least 4 points. And I'm going to show you how to add extra curves on that. So we have, like, for example, 4 points, and that is going to be our curve. And when we add other 4 points, we are going to create another curve. Then it's work sort of in this way. Maybe it's smaller. And this is going to be a spline where the connected point is a knot. We are going to have even what we can call tangents. There are the point close to our knots, and they define the curvature of that segment of the curve. The type of tangent you can have it is going to define your continuities of the curves, but we are going to a different type of algorithm, etc., etc. So even the matrix, the coefficient matrix that we are going to use it depends what kind of curve you're doing, like the Hermite or the Cactum. They have a different coefficient. Just a small note before starting to do it. Robert Stratton made a very amazing tutorial on CG Circuit about generic Bifrost and math. It's very interesting, where it talks about how to build Hermite curves with the computation of tangents, use space. Is going much more in deeper than this tutorial. So I highly suggest to watch that one too. I will write the link below, so if you want to give a look. So now that we have all this explanation, let's actually start building our base curve. So first things first, let's create a few transform. Because it's a cubic, and like I mentioned, I need to have 4 points. If it's a quadratic, 2, a linear one, and so on. So let's build our Bifrost node. And first things first, we need to have our inputs. So let's build a value matrix. This one I'm gonna array, and let's connect it. And we can call this one in transform. Here we go. Now that we have in transform, let's connect with actually our Maya scene. So let's get the node locator 2. There you go, locator 3, locator 3 and 4. So let's get the word matrix and connect to the in transform. Word matrix. Oops. Word matrix. Word matrix and word matrix. Here you go. So now we have all the connection that we need. 1, 2, 3, 4, and we can start to build our code. So we don't need it actually our the output at the moment, so we can remove it. So first things first, let's get the matrix SRT because we need to have the point position. And from that, let's see. Actually, I forgot to show you. Let's see the polynomial for a cubic Bezier. So that is the math that we have to do, and you can see it's split in 3 parts. The first part is the computation of the u value that we want to compute, what is the final position. This matrix is the coefficient, and like I said, this is the Bezier. Only small notes. You're gonna to write me on the upper diagonal. This because the way then Bifrost manage matrices compared to this formula. And this is a 4x3 matrix, then is our open position. Of course, we can use a 4x4, but we need to transform our position in a vector 4. So this is a constant. This depends by the u, and this depends on our point position. So now we have all the all the information, let's start actually building a U value. So our view, like the same video that I did before with the Bezier curves, we use the clam. We don't need it, but here you go. So now we need to have the power and our U. Actually, if you see in some uh, in other page, wherever, you can see the formula with the t instead of u. It's most used t sometimes. It's the same thing, just to let you know. So this is 0, this is 1, this is 2, this is 3. Let's build a 4 by 1. So this is going to be 4, vector 4. You can open it, connect, connect, connect. Oops. So you're going to see me now use power 0, power 1, just for the sake of the explanation. But of course, we are going to replace this one with a static one, and this is going to be a direct connection just to optimize the code. But at the moment, just as for the explanation, I like to keep it this way, but we are going to change it. So now let's build our coefficient. This is going to be our matrix. And like I said, this is going to be 3, 1, minus 3, minus 3, 3, minus 1. This is going to be 3 minus 6, 3, 3 minus 3, and 1. Oops, I pressed F1, sorry. So let's double check it. 1, 3, 3, 1, minus 3, minus 6, minus 3, 3, 3, minus 1. Okay. And now the last things we needed is our 4 by 3, then is our point. So matrix 3 by 4, sorry, my mistake. If you open it, you can see we have 4 elements. These are our 4 points with the position. So now we need to get this element from the array, get from array. Let's connect the transition, copy, copy, copy. This is going to be 0, element 1, element 2, element 3. Let's double check 0, 1, 2, 3. Here you go. 3. See, sometimes I don't. Okay. And now let's connect all this here. Okay, so now we build all these 3 area, and we just need to multiply now with each other. So matrix multiply. So we're going to multiply our coefficient with our u variation, and we're going to multiply our point position matrix with our variation. If you see the result at flow 3, then it's perfect for what we need. And actually, this one, it's almost all for a single point, of course. So let's build a construct points. Let in, let's connect point scope, just so we can visualize it, and terminal. So this is going to be the output. This is going to be our true model. Let's make these ones bigger because it's always very small. Okay, you can see the point there. And of course, we are at 0. So when we move it, here you go. You see, it's already have there's a curvature and everything. If you want to see like all the points, we can create a sequence. 11 step 0.1. Let's connect this one. Here you go. And we have our curve with a polynomial resolution. So let's build even the strands, always from the points, and just put it there. Here you go. Awesome. So now that we have this one, okay, first, like we say, just let's optimize these things because this doesn't make any sense. So this one is going to be here, and this one, script value, is going to be 1. Here you go. It's absolutely the same things. You can notice that. So now then we have all these steps, we can actually easily isolate what is our Bezier computation. Here you go. We can call this one Bezier. There you go. So, well, our curve actually is going to be our cubic. So our inputs, this is how you write cubic anyway. There you go. Cubic curve. So the inputs are 4 points. The return are number of points, depends of our samples. Actually, let's expose a sample. So depends of the sample. Let's transform to float. We want to subtract 1. Divide. Sorry. What we need is divide. We want to divide 1 by our number of elements. This is going to be our steps. And now we can have the steps here. Here we go. We can even expose this one, samples. Here we go. Let's input there. And of course, we want to change this one as well. Okay, so now we have our sample code. So now what we have to do every time we add like 4 points, we can create another curve. So to simplify all this process, I want to now build a curve from 2 points. This means the other 2 points we need to compute at these two points. Let me explain. So what we are going to do is we're using the matrix here, information, to find, well, we can choose which axis we want to use it to find like the tangents. Let's say at the moment, these axes here. So we find these are the 2 points and we end up with our matrix represent 0, and 3. And the vector of our matrices represent 1 and 2. Okay, so to do so, we're going to create another compound, and this compound help us to from transform to 4 points. Here you go. So the same things here. Let's extrapolate everything that we need. Get from array, and we get index 0 and index 1. 0 and 1. These are going to be our 2 inputs. Transform 1 and transform 2. And from these 2 transform, we want to output 4 points. So first things first, let's matrix to S. Actually, instead to use matrix S30, I want to use actually value. I think it's just better. In theory, there is a better computation on that. We can just input this one, and we can use the last row for our position, and so 0.0. But we need to convert vector 4 to vector 3. Vector 4, vector 3. So this is going to be our print 0. Just to create a multiple output, we're going to change this one later. Here we go. Name 0.1, 0.2, last but not least 0.3. So now we have these 4 that we can easily connect. Everyone disappeared because it's actually just 1 point. It's all here. So we have our position, and from this position here, we want to find a vector, and from this vector, find our new P1. The way to do this one is to get all the matrices, multiply from multimatrix, get the vector, This can be matrix vector 3. So we can compute this one with this vector. These represent the vector that we want to use. For example, if I put like this, x, we are going to use the x-axis here. Now we have a vector that represent one of the three axes of my matrices. We want to add it to the point. Actually, let's do this one. It's the same. Order doesn't matter for the add, but I found just cleaner. And this is going to be our final position. We can add some feature on that. So at the moment, we just build. We have our point with the axis. We choose which axis to use. Let's say this one. What we want to do now is normalize it and normalize it and create a scale value so we can position anywhere and we can add the weights of the tangent. Yeah, and that's it. So we have our vector here. This vector is float 4, by the way. Because it's float 4, if you come back here, you're going to have an error. Float 4, so we want to output here vector 4 to 3. There you go. Come back here, you can see now float 3, and here is where we need to check out. Okay, so this is our vector. So we want to normalize. Actually, I want to keep the normalization for later because I want to show you actually another things first. But I want to have a multiply by a value. So we're going to have this one here, this one there, and it's going there. Perfect. This one is going to be an input. And we have to do all this process here for the second point as well. So this one is the common, this is the common. You can select everything, copy and paste. We need to change the matrix here. So this is going to be our second point. Inputs, vector, blah, 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 some, etc. Okay, so this one is going to be our point 2. And this one is going to be our point 4. Here you go. There is another things we have to do, but let's check what we have now. So it seems actually kind of work, sort of. We're going to see why these things don't work. First is the scale because it's 0. So let's increase this one to 1 at least. Here you go. So if you see display, okay. We use x as a tangent. So let's expose which tangent we want to use it. So let's do like this. Tangent vector. And for example, if we want to use the y instead x, we can just select vector y. If you see now is on y. And we even increase the scale. Here you go. If we do prefer to use z, just put 0 here, and now is z. And we can even combine the vector together to have different tangent space. Okay, let's come back to one. There is another thing I want to change. So now, if you see, the tangents are all both on x-axis and a positive one. But actually, I want then go out from x. So x positive for the first is good, but when I arrive to my last point, it need to be on the negative x. So I want to use the node like this, the point like this. So the way that we want to go, when we are here on the multiply, we can create a value. We can use -1 here, but we can actually sample as float and do -1. Here we go. And now we have the point going in and out. So one things, you see me moving like the scale on this node here. This actually works fine, but because we are taking literally the x value of this transform matrix, we can scale it and it will work the same way. Though this works if we don't normalize. If we actually normalize, so we use this one here in both sides. Now the scale will not work anymore. You can only use the tangent scale, and no one stopped you to create a if condition to switch it. I can show you actually. So let's create a if. If it's true, I want to have the normalized. If it's false, I want to use the not normalized. Here you go. We can use the same inputs here. Normalize. Actually, yeah. So let's expose this one. So if normalize is on, there's nothing different. See, nothing happened. But as long as I turn off the normalization, it works. Awesome. So now we have our transform to points. We have our cubic. What we want to have, we want to concatenate multiple points to create a spline. So what we need, we don't need this one anymore. We like these 2 points, but we want to have these 2 points inside a for each. So let's use for each. Here you go. Now what we want is this cube points. Then we sum it and create a very long list of points. We want to have the 2 transfer as an inputs. Well, we want to have everything as an inputs in this case, but the 2 transform is going to be set as iterator. Here you go. This is going to be our plug. Here you go. And what we want to have now, we want to slice this transform into list. I already did this one in my previous video, so go to check there. I think you can find much better information on that. So we want to have this one actually. Let me see. We want to have tangent scale, tangent vector, tangent vector. I don't want actually. But why not? Tangent scale, let's say 2, tangent vector 1. Normalize off is fine. Okay. So sample, we need a sample, of course. So for slicing this list in 2, we want to have the slice array. We want to have array size. Let's get all the list, subtract by 1. We want this list be splitted from 0 to this. If you remember, this is going to be our endpoints. This is going to be our endpoints -1. So this is going to stop n -1. We do the same things, but this time it starts to 1 and it's going to finish to n. If we connect now these 2 slices, here you go. We are going to have our spline, cubic spline, with automatically vector based on transform. And of course, if I connect this one even on the strands, we have our strands. Awesome. Thank you very much to watch this video. Catch you next time. Marco.